Hello, friends. Welcome to Multiverse. And if you remember, last week we covered a very different type of a neutron star called magnetar, and we covered in detail. In fact, we are now discussing neutron star and taking it even further. And today we have a very special thing to discuss in neutron star, and that is called the strange stars. And it seems that the strange stars are made of the most stable material in the universe. How is that possible? What are the factors that a neutron star becomes a strange star? What is this strange matter? All that we will be discussing today. Well, first of all, we need to understand that neutron stars are called neutron stars because they are made of neutrons, and because everything is made of neutron inside the neutron star, there are no elements like iron, oxygen, hydrogen, helium, etc. They are all degenerated neutrons. That there are no electrons, there are no protons in the neutron star, and because of that they are very special because there is no charge between the atoms of these matter, and everything is made of neutron. And because of this, the density can be very high. Density of a neutron star can be extremely high, and it will also have lot of material in it in a very small place, because since there's no charge between atoms, because everything is neutrons, they will not repel each other, and hence they will fit very nicely together. And the body which will be made, which is neutron star, will have a lot of material in a small space, and hence neutron star also exhibit a lot of gravity, because a sun size material can shrink into a neutron star which is not more than 20 kilometers in diameter. So this is first of all the special aspect of of a neutron star. Secondly is that the neutron star themselves are very extreme objects. They exert a lot of internal pressure because of a very high gravity. The pressure within a neutron star is so extreme that the debate is that how the internal structure of neutron will be able to support the entire weight of the star. Estimate is that 1 teaspoon material of a neutron star may weigh as much as the entire Mount Everest, billions of kilograms, billions of tons, just 1 teaspoon. And just to add a caveat here from the Marvel comics, and if you are following the Marvel comics, the Mjolnir, which is the hammer of Thor, is heavy. You know that nobody else can lift it but the god of thunder, Thor. And if you are following the Marvel comics, they keep saying that the Mjolnir was made from the core of a dying star. So I think this is just a caveat. We move on. We don't want to bring the Marvel comics here since we are having a scientific discussion. But the whole point is that the neutron star exert a lot of pressure to its interior, to the inside material, because of the very high gravity. And because of this high gravity, here I would like to draw your attention to the principle, very popular principle in physics, which is called Pauli's exclusion principle, which actually means that if there are two objects in the universe, they cannot occupy the same space in space-time at the same time. So if there is one electron, there is another one, they cannot occupy the same space. If there is a proton and electron, they cannot occupy the same space at the same time. Either they collide and explode into an explosion, become something else, or they just move on so that that space is now vacant, and the other particle can occupy that space. So this is called Pauli's exclusion principle, and this is the laws of physics, and this has been proven also. So in case if there are two objects now coming closer, very close, then they will have to either annihilate themselves into energy, or they will have to collide and move on to different places. That is why the Pauli's exclusion principle is true. However, inside a neutron star, when there is so much pressure being exerted by the entire star, then something peculiar happens. The neutrons which are inside the star will have so much pressure, and this pressure is has been calculated also. It will be so high that these neutrons will then start violating the Pauli's exclusion principle, which cannot happen. There is no matter in the universe which can violate this law where they start occupying the same space in the universe, in space-time. So when the two neutrons are pressed together so hard that they start, neutron is a fundamental particle, and therefore it cannot change its shape, it cannot get squeezed like a orange. They start acquiring the same space which has been prescribed not to be not as per the Pauli's exclusion principle. And because it cannot happen, therefore something very strange happens inside the neutron star. And before we go there, we must also tell that the neutrons inside the neutron star are made of the quarks. So far we have identified that the quarks are the fundamental particle along with the binding energy make these fundamental particles which are bigger, like neutron, proton, electrons, etc. So each neutron will have 3 quarks, and since there is so much pressure on the neutron, it has no place to go, it cannot move around, and there is so much pressure on the inside of the neutron star. Then gradually the neutrons inside the neutron star start to degenerate into something called quark matter. They will no longer be neutrons. They will break apart into individual quarks. And because of that, the binding energy is released and the temperature rises to trillions of degrees inside the neutron star. So this is the process by which it generates heat, and the matter degenerates into quarks. And this is where the true nature of a neutron star comes alive. The outer layers are made of the neutrons, which are the basic material available in neutron star. But the inside of that will be an ocean made of quarks. So there are no particles; it's just the quarks in their natural state floating around. And since the material is made of quarks, it is so energetic that it generates huge magnetic force, huge heat and huge magnetic force. And this material, your quarks cannot exist freely in the space. So this material is a very strange type of material. I mean, you can imagine the basic building blocks forming a sort of an ocean and floating around, creating all sorts of properties inside a neutron star. In other words, a neutron star is nothing but a large neutron. It's not a star like a neutron, but it's one large neutron. Therefore, what happens next? The ocean will continue to exert pressure on the core. So when you have the outer layer made of neutrons, the inner layer is made of quark degenerated matter which is floating around. It's like an ocean, but the pressure continues to increase to the core. So estimate is about a kilometer diameter of the core gets so much pressure that the quark material will not be able to withstand that pressure, and then they themselves start violating the Pauli's exclusion principle. That means two quarks cannot occupy the same space in space-time, and something very strange happens. Hypothetically, we have no mechanism to test this whole thing out, but something very strange happens here, and that is that the quarks start becoming strange quarks. That means they start developing a property which is against the known laws of physics. They can withstand a spark, withstand the high temperature, withstand the extreme pressure, and will not violate the Pauli's exclusion principle, and they continue to remain as quarks, separated, and without falling into each other. And this property makes them something called strange quark. And these strange quarks are supposed to be the most stable matter. That means nothing can affect them. Very high temperature cannot affect them. very high pressure cannot affect them. They actually acquire that place in their in our periodic table as a strange matter, and the core is then made of something called strange matter. And there are other properties of strange matter which are very strange. The strange, once the core of the star becomes strange core or made of strange matter, whatever it touches, it is contagious. It start making other things which are surrounding the strange matter into strange matter into itself. So whatever it touch will become a strange matter, and that is why the strange matter is something very, very peculiar. Strange matter also shows signs of superconductivity at normally superconductivity is achieved at a very low temperature. When we bring down the temperature to something very, very low, then the superconductivity, that means electricity will pass through without any resistance. But the strange matter also shows the superconductivity normally as part of its property. So something that we know so far, because we have not been able to examine the strange matter, because even if we get this strange matter into our lab, whatever whatever connectors we have, or whatever indicators we have, will become a strange matter just by touching it. So that is why it is very, very hard to imagine what kind of matter this is, and it is contagious, as I said. So if it touches something, it converts that into itself. So normally the assumption is that the core of all neutron stars would be made of something called strange quarks, which is nothing but strange matter. And the neutron stars don't last for very long. Either they collide with something, or they cross the Chandrasekhar limit. That means 2.5 times the mass of the sun. They cannot be more than that. And if they acquire more mass by absorbing more material, they explode into a black hole. So we have not seen neutron star, the entire neutron star, becoming a strange star so far. But whenever there are these big explosions, like two neutron star colliding, or neutron star erupting into a nova, becoming a black hole, the chances are these small droplets of strange matters can be distributed across the space, and they may be floating around, and whenever they and they can exist without any problems. Whatever the condition in the space would be, their nature will never change. They will always be strange matter. And the estimated size of these droplets can be from very small micro sizes to up to a kilometer. So scientists now believe that the universe may have a lot of these strange matter droplets, and they are floating around, and if they come close to any matter, they will convert whatever they touch, they will convert into strange matter. So there could be a chance that if a strange matter enter atmosphere of Earth, it start converting Earth into strange Earth. So that is one possibility. So far we are only talking theoretical, based on the known laws of physics, and what science we know, what we can examine. But this is again proven theoretically. We have not seen any strange matter. But if it is true, I think more research is required to ascertain the nature of this strange matter, and what was the how the universe existed just after the Big Bang. Was everything made of strange matter, and then gradually strange matter degenerate into matter that we see? We have no idea. So more research is required. Probably we will be able to know more once the James Webb start examining things very early in the early part of universe. But this is something which is so surprising, and something it is worth exploring more. So friends, if you know something more than what I have covered in today's video, do send in your comments. And as always, thanks for watching, and I will meet you in the next one.